Welcome to the video on Gauss elimination method. Um, in this video, we are going to look at simple problem solving linear systems systematically using Gauss elimination method. So, in the earlier lecture, we see the three solution types that can arise in a linear system. From lecture 1 we learned the system can have a unique solution or no solution or infinite number of solutions. Now in this lecture we are going to study how do we find these solutions. Why Gauss elimination method to find the solution is important and effective. So the big idea behind Gauss elimination method is that we are transforming the given system to the triangular form. Why triangular form? In the triangular form, the solution process is easy and systematic. We can use back substitution to find the solution of the system. So our fundamental goal here is to change the system from the given form to a triangular form. On my left hand side you can see the general system, and in right hand side you can see a triangular system. So what is in my left hand side? There you can see the entries of the augmented matrix. So A11, A12, etc. A33 is there, and the B1, B2 columns after the vertical line is there. So all entries may be non-zero. But at the same time, on the right hand side, look at that matrix Aij, the matrix A is upper triangular, means the lower triangular entries are zero. So if we can change the system from a normal form to the triangular form, the solution process is easy. That is, we are transforming a complex system to a simple triangular system. Let us look how this happens. Now look here, the upper triangular system look like 2x1 plus 5x2 is equal to 2, and in the second equation there is no x1 term. In the second equation there is only 13x2 is equal to 26. Lower rows have more zeros. On the left, last equation has only one unknown. This is the speciality of here. The final equation or the second equation here has only one unknown, which is x2. So it is easy to solve the system. How? So the given system was 2x1 plus 5x2 is equal to 2 minus 41x1 plus 3x2 is equal to 30. Now we will transform this to a triangular form using elementary row operations, means systematic changes. So which are those elementary row operations? There are basically three types of elementary row operations. They are multiplying a row by a non-zero constant, add a multiple of one row to the other, or interchange two rows. So there are three elementary row operations you can do on a matrix to transform from its given form to a triangular form. They are multiply a row by a non-zero constant, to add multiple of one row to the other, or interchanging two rows. Even if you are doing these processes, these three steps to a given system, the solution will not change. So let us practice it. So our system is 2x1 plus 5x2 is equal to 2 and minus 4x1 plus 3x2 is equal to minus 30. So I will form the augmented matrix here. So I will send the right hand side B elements to the matrix, and if I form the augmented matrix 2, 5, 2, minus 4, 3, minus 30. Now I will do this operation. So my original system is 2, 5, 2, minus 4, 3, minus 30. So I will replace the second row with row 2 plus 2 times of row 1. What happens here? You add 2 times of row 1. 2 times of row 1 is 4, 10 and 4. So when you add 4, 10 and 4 to this row, here you will get 0. That is why I change the second row to 0, and other additions will also performed. Then it will become 10, 2 times 5 is 10, 10 plus 3 is 13 and minus 26. Now what happens? The system, the original system has changed to a triangular system. So here it is 0. That means it is triangular. Or otherwise, in the triangular system, the coefficient of x1 is what? 0. So it is easy to solve it. How? So what we did here, we take row 2, multiplied by row 2 by 2, and you add it with the first row. So we will get x1 term eliminated. This is the calculation we have done here. So by doing this elementary row operation, we have eliminated what? X1 from the second equation. So what is its advantage? Its advantage is there is no x1 in the second equation. So we can by 3 steps we can actually find the solution. That is step 1, solve the last equation for x2. So that is easily possible. And substitute the first equation with the solution of x2, that is we got from the second equation, and solve for x1. Then we will get both x1 and x2. Let's do that. Yes, from the second equation we have 13x2 is equal to minus 26, and divide both by 13, we will get x2 is equal to minus 2. Now we substitute x2 is equal to minus 2 into the first equation. Then 2x1 plus 5x2 is equal to 2, and by solving step by step we will get x1 is equal to set. X1 is equal to in fact 6. We got the complete solution right now. So what is it? X1 is equal to 6 and x2 is equal to minus 2. The equation, the system is completely solved. And we can verify this by back substituting the equation. You can see that the equation is satisfied by our solutions what we found. So the solution is correct. Here what we did actually, we have done actually 4 steps. Step 1, write the augmented matrix. We frame the augmented matrix. Step 2, use row operations to create zeros below the diagonal. Below the diagonal we've set it into 0. And step 3, back substitution from the bottom equation. We find the variable in the third equation, then go up and find all the solutions. Then after that we verify the system. We can do the same set of operations actually. We can do the same set of operations for even if there are for an m by n system. That means even if there are more number of equations and more variable, we can actually work this system or work this process. So why this Gauss elimination is so powerful? Because here we have a systematic method, a clear algorithmic approach to solve a system. And second, it is universal, but for any system, any size. If the number of equations are higher, if the number of variables are higher, means there are many variables, then also you can step by step, you can proceed to the final solution of the equation. So it is universal. It is also efficient. Even if there are 1000 plus equations, so many equations or many unknowns, you can easily follow this equation. This is basically algorithmic, and it has foundation for computer software. It's used in MATLAB, Python, Excel, etc. So basically, Gauss elimination method is an algorithm. So you can program it. That is the strength of the Gauss elimination method. So what we studied today is, our goal was to transform a normal system or a given system to a triangular form. And the method we used is elementary row operations. We have studied there are three elementary row operations. Then we solved by back substitution from bottom equation to the up equation. Finally, we verified the solution. So, in the next lectures, we are going to handle larger systems and some special cases. So thank you for listening to this lecture. If you have any doubt, you can comment below.